Namaste dear students. We have started chapter number 2, Mechanical Properties of the Fluids of 12th standard, and in that chapter we have explained angle of contact in lecture number 6 in last lecture. Today we see the effect of impurity and temperature on surface tension and excess pressure across the free surface. We see these topics today. Before that, we discuss very small topic of the angle of contact, that is factors affecting angle of contact. There are three factors which are affecting angle of contact, and first factor is nature of the substance. If we change the liquid, there will be change in the angle of contact. Means, for example, if you take water and clean glass, pure water and clean glass, then for pure water and clean glass, angle of contact is 0 degree. If we change the liquid, means if we use kerosene, angle of contact will be 26 degree. Means it will depend, angle of contact will depend upon nature of the substance. Then second is impurity added. If there will be impurity added in the substances, there it will cause the change in angle of contact. Means in water some extra impurity will be added, like detergent or if phenol are added, then it will change its angle of contact. So this is second factor. Then third factor is temperature. If temperature is increased, there will be decrease in angle of contact. Means for increase of the temperature, there will be decrease in the angle of contact. So these are the three factors on which angle of contact depend. Now let us see what are the effects of the impurities on surface tension. Means in water, if some impurity is added, like common salt. If common salt is added in water, means common salt is soluble. It is a soluble impurity. Then the surface tension of that solution will increase. There is increase in the surface tension if we add common salt. Then this is one property, or this is one effect of the impurity. If soluble impurity is added, there will be increase in the surface tension of the liquid. Then if the sparingly soluble substance is added in the liquid, means if you take water and in water detergent is added, म्हणजे पाण्यामध्ये जर समजा आपण पावडर जे असतं कपडे धुण्याचं पावडर, ते डिटर्जंट पावडर जर पाण्यामध्ये टाकलं, if we add the sparingly soluble substance in the liquid, then it will decrease the surface tension. There will be decrease in the surface tension. So this is second effect of the impurity on the surface tension. And because of this property, means if the detergent is added in water, there will be decrease in surface tension, and because of the decrease of the surface tension, the liquid will go to the fabric and it will remove the stains, or it will remove the dust from the clothes. So this is the reason why the detergent is used for washing of the clothes. So this is the second point. Sparingly soluble impurities will decrease the surface tension of the liquid. Then Next is insoluble impurities. If insoluble impurities are added in the liquid, then it will decrease the surface tension. Now in this case, what will happen if insoluble impurities are added into the liquid? There will be decrease of the cohesive force, and that decrease of the cohesive force will decrease the surface tension, and because of that, if the mercury is in contact with the dust, it will not form the spherical droplets, or it will not form the shape of the sphere. And when that dust is removed, that mercury will form the shape of the sphere. Mercury drops will form the shape of the sphere. This is because of the impurity which is in contact with the mercury. So this is the third point. If insoluble impurities are added, then if insoluble impurities are added in the liquids, the surface tension of the liquid will decrease. So this is one effect of the impurity. Now we see what is the effect of the temperature. When temperature of the liquid is increased, if there is increase of the temperature of the liquid, then there will be decrease in the surface tension of the liquid. So this is the effect of the temperature on the surface tension. And normally the new clothes, new cotton or new clothes are, it is written on the clothes that wash with the cool water. म्हणजे नवीन जे कपडे असतात त्याच्यावर असं लिहिलेलं असतं की थंड पाण्याने धुवा, वॉश विथ द कूल वॉटर. याचं रिझन असं आहे की जेव्हा वेन द टेम्परेचर ऑफ वॉटर इज लेस, मीन्स इट इज कूल, then its surface tension will be larger, and because of the larger surface tension, the water or that solution will make the less contact with the fabric, and the color of the fabric will not be removed. This is the reason. Will not be removed, and this is the reason. म्हणजे ते फॅब्रिकचा जो नवीन जे न्यू जो कपडा असतो त्याचा कलर निघू नये म्हणून ते थंड पाण्यामध्ये धुण्याची सूचना त्याच्यामध्ये असते. थंड पाण्याचं जे सरफेस टेन्शन आहे ते गरम पाण्याच्या सरफेसपेक्षा हे जास्त असतं, आणि म्हणून त्याचा जो कॉन्टॅक्ट असतो फॅब्रिकशी, म्हणजे त्याचे धागे असतात त्याच्याशी कमी येतो, आणि त्याचा कलर हा निघत नाही किंवा कमी निघतो, हे त्याचं कारण असेल. सो दिस इज द इफेक्ट ऑफ टेम्परेचर. नाउ इफ यू डिक्रीज द टेम्परेचर at particular temperature, or if you increase the temperature of the liquid at particular temperature, surface tension will become zero, and that temperature is called the critical temperature. म्हणजे एका विशिष्ट टेम्परेचरला हे एका विशिष्ट टेम्परेचरला हे जे सरफेस टेन्शन असतं लिक्विडचं ते झिरो होतं, आणि त्या टेम्परेचरला म्हणायचं आहे क्रिटिकल टेम्परेचर. सो दिस इज द इफेक्ट ऑफ टेम्परेचर ऑन सरफेस टेन्शन. नाउ लेट अस सी excess of pressure across the free surface. Means if we take the free surface of the liquid, suppose this is the liquid and this is the free surface of the liquid, then free surface of the liquid is acted upon by the force due to surface tension. म्हणजे हा जो फ्री सरफेस आहे, म्हणजे हे प्लेन आहे, लिक्विडचं सरफेसचं हे प्लेन आहे, हा जो फ्री सरफेस आहे याच्यावर एक विशिष्ट फोर्स ऍक्ट होतो सरफेस टेन्शनमुळे, अँड बिकॉज ऑफ दॅट फोर्स, because of that force, if the shape of the liquid is plane or convex or concave, the pressure on the both sides, above the liquid and below the liquid, will be different or it may be same. It will depend upon the shape of the liquid surface. Now, normally, if we consider molecule A just above the liquid surface, then there will be force acting on molecule A, and this force is force due to atmospheric pressure. Means because of the atmospheric pressure, the force is acting on molecule A. Now here, if the surface is plane, the force due to surface tension, which is acting on the both sides equally, means equal force is acting due to surface tension on the surface of the liquid, on the plane surface of the liquid, and because of that, the net force due to surface tension acting on this surface at this point will be 0. Means because of the surface tension, the net force acting will be 0, and therefore the pressure at point A and pressure at point B will be same. Means when we take the plane surface, the pressure difference at point A and B will be same, and A and B points are at the same levels. They are at the same distance, they are at the same levels, and so pressure difference will be 0, or you can say that they have equal pressure. Now suppose we take a convex surface. This is a convex surface from the if we see the liquid from the above, then this is a convex surface. Then for convex surface, the force due to surface tension are acting tangentially in the downward direction. Means there are forces acting tangentially on the surface at this point in the downward direction, and therefore net force acting on the surface at this point, or net force acting on the surface, is in the downward direction. So from the convex side, there will be two forces acting. Means one is the atmospheric pressure, force due to atmospheric pressure, and second is force due to surface tension, and due to that the pressure on the concave side, means this is the concave side of the liquid, pressure on the concave side will be greater than pressure on the convex side. So here pressure on the concave side will be greater. Now take example of the concave liquid surface. If you see, this is liquid, concave liquid surface. If you see from the top, this is the concave liquid surface. Now in concave liquid surface, force due to surface tension is acting in upward direction, because this is a force tangentially acting. This is force due to surface tension, which is tangentially acting in upward direction, and therefore this force Ft is in upward direction, and therefore the and this force, atmospheric force, is in downward direction. Fa is in downward direction, and because of that, the force which is acting on this concave side, means here this is the concave side, and from this concave side the force acting is more, and therefore the pressure on the concave side, here also pressure on the concave side will be greater than pressure on the convex side. Means pressure at point A will be greater than pressure at point B. So for three different surfaces, pressure will be different. Means if it is plane, pressure will be equal, and in this way the end of the topic. Thank you very much.